All right, Grizzly Risley is going to get you guys through some exponential growth and decay word problems today. Now, people hear word problems, they freak out. The good news is exponential word problems are very easy, actually. Okay, so a function is growing exponentially if it's increasing by the same percent every year. Let's underline both of those. And here's the formula. Y equals C times, parentheses, 1 plus R, parentheses, to the T power. This is kind of like our function that we were just writing before, but instead of using A, we're using C for the initial amount. And instead of using B, we're using this thing called 1 plus R, and R is the growth rate. And we need it to be represented as a decimal. So R is the growth rate as a decimal. And T is just going to be time. So T is time in whatever units the problem's in. All right, guys, quick review. How do you turn a percent into a decimal? So if I said 15%, how do you turn that into a decimal? Do you guys know that you move it 2 spots to the left? So it's just 0.15. Can we do one more? What about 2%? How do you write 2% as a decimal? Well, you move it over 2 spots to the left, and if there's no number there, then you add a 0, so 0.02. Okay, you're going to have to do that a lot today. So if they give you a percent, you always have to write it as a decimal. All right, so this is really easy. We're just going to read the problem and see if it's exponential, and then plug stuff into the formula. Okay, so first I'm going to write the formula. Y equals C times 1 plus R to the T power. Okay, so first step, is this problem represent an exponential situation? A newly hatched channel catfish typically weighs about 0.06 grams. During the first 6 weeks of life, its weight increases by 10% each day. Okay, there's your key that it's exponential. If it's increasing by the same percent every time period, it doesn't have to be year. Okay, so yes, it's exponential. Let's see what we know. So what's the initial amount? How much does this catfish weigh when it's born? A newly hatched blah, 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 0.06. That is C. That's your starting value. Okay, and then now what's R? It's 1 plus R. R is the growth rate, but written as a decimal. So how do we write 10% as a decimal? Well, you move it 2 spots to the left, so it's 0.10. Okay, moving along, and then T is time. And it says, write a model for the weight of the catfish during the first 6 weeks. So T is 6. And then all you do is type it in the calculator. Okay, everyone's good on that? Nothing hard here. So we're going to type this in. So it's going to be 0.06 parenthesis, 1 plus 0.10, close the parenthesis, and then caret 6. Raise it to the 6th power. And it's increasing, so it should go up. Let's round it to 2 decimal places. So 0.11. 0.11, and this is in grams. So grams. And I know he's still small, but he went from 0.06 to 0.11, so he did grow. All right, so that is an exponential growth model. Now, if you guys flip it over, we're going to do the same thing but exponential decay. And the good news is, same exact formula, except now there's a minus instead. So super easy. So a function is decaying exponentially if it is decreasing by the same percent every time frame. C is still the initial amount. R is still the rate, but always as a decimal. And in this one, R is called the decay factor, and T is still the time. All right, so we're just going to try one of these. So first we have to read it and see, is it even exponential? You bought a car for $16,000. You expect the car to lose value or depreciate at a rate of 12% each year. So because it's decreasing by a percent, it is exponential. Okay, so here's the model. Y equals C times 1 minus R to the T power. All right, let's plug in what we have here. So starting value C is 16,000, right? That's how much it that's how much it costs when you bought it. And then it's 1 minus R is 12%, but remember you have to turn it into a decimal by moving it 2 spots, so 0.112. And then we're raising it to the, let's do part B first. Find the value after 8 years. So T is going to be 8 for part B. All right, let's plug it in. So it's 16,000 times 1 minus 0.12, all raised to the 8th power. And you guys should get, and this is money, so, oh man, cheap now, $5,754. We'll just round to the nearest whole number. Okay, so that's part A, or part B. And then part C is the same thing. Find the value of your car after 5 years. So we would use the same model, but just plug in T is 5 instead. So that one, I'm going to cheat a little and go back up and edit the 8 and just change it to a 5. And if you don't know how to do that, I could show you tomorrow. And this one would be a little more more money because as much time has not passed. So $8,443 for 5 years. All right, that's it. Growth and decay exponential models. Not too bad. One's a plus, one's a minus. Thanks for watching. See ya.